So we learned that the mole was three things. Okay, so particles, and that could be atoms, it could be ions, it could be molecules, and it could be formula units. There was a number associated with that. Do you guys remember what the number was? 6.02 times 10 to the 23rd is probably enough. And this is equal to 1 mole. Okay, so that's one conversion factor that we can have. All right. There were two more in the video. I'm hoping you caught them. The molar mass is also equal to 1 mole. So if we were doing, let's pick something that's easy, CaCl2, and we wanted to find the molar mass of that. All right, so if we were doing CaCl2, we have to look up the amount of each atom. So calcium has how many calciums? Louder. 1. Cl has how many? 2. All right. We're going to look at the masses on the periodic table, and we're going to round them to whole numbers. So calcium's mass is 40, and chlorine's mass is
35.
Right, 35. So when we do this math, we get 40 and 70, and then we just add them all up together, and this is going to be, let me slide my paper up a little bit. This is going to be 110, and the unit is, it's 110 grams of CaCl2, and this is equal to 1 mole of CaCl2. This is called the molar mass. And it also gives us a conversion fact for 1 mole. So these numbers are different for every formula, as we figured out yesterday when we were playing bingo. Depending on whatever's in the formula, you add it all up, and that is equal to 1 mole. Back over here to the Avogadro's number, this number never changes. It's always equal to 1 mole. Okay, kind of like we talked about a dozen donuts. You can have a mole of particles, and they all have different masses. We could have a dozen donuts, and depending on whether we pick the Boston cream or the glazed or whatever, they all have different masses. Okay? So that's 2 conversion factors. We have the Avogadro's number 1, we have the molar mass, and there's a space here for a third one. Did anyone pick up the third one from the notes last night? Molar volume. It's going to be the volume in 1 mole. Now, molar volume is at a specific set of conditions that we don't need to worry about right now. It's at a thing called STP, and that means standard temperature and pressure. You don't need to worry about it. We will get to STP when we do gas laws. It's just something that's going to appear in a problem. They're going to say this is at STP. You can just ignore it for now. So molar volume is that 1 mole of a gas is going to be 22.4 liters. Okay? And that is also not going to change, kind of like our particles never changes. So 22.4 liters never changes. It's always equal to 1 mole. 1 mole is also equal to 6.02 times 10 to the 23rd particles. And 1 mole equals however many grams the substance is based on its molar mass. Make sense? Okay, so what are we going to do with this? Well, we've done conversions where we changed from like miles to inches. You went miles to feet, feet to inches. Well, guess what? You now have conversions that can change from moles to grams, moles to liters, and moles to atoms, ions, molecules, or formula units. Let's look at a couple. Yay, I know, I can tell the excitement. It's astounding. It never ceases to amaze me. All right, so let me make up a problem. Let's see. Here's your question. It's going to be how many molecules in 2.3 moles of CO2. So they're giving me a unit, moles of CO2. Here for the first time, you really have to include both the amount and the substance. So in the past in tests, you've gotten 1 point for units. We're now going to get 2 points for units because you need to have both the mole and the CO2. You need to tell me what it is. It matters what the substance is, especially if we're doing grams. So make sure that you're using both parts of the unit there. All right, we're going to start with the number they give me, 2.3 moles of CO2. And when they give you a number, you always put it over just plain old 1. This should look familiar. What are we going to do? Convert, yes. What do you want to, where do you want to start in this fraction? Go ahead.
Put 1 mole on the bottom.
1 mole on the bottom, because everything that we had on this screen here, they were all equal to 1 mole. Okay? So we're going to put 1 mole, and we're going to keep the CO2. It's good practice to keep the substance as well. It'll help you in the next chapter. So 1 mole CO2. All right? We are being asked to find molecules. Hold on, Katie. So which one of these would we be using to go to molecules?
Avogadro's number.
Yeah. Molecules are over here. So we're going to use this number, 6.02 times 10 to the 23rd molecules. We're going to put that on the top. 6.02 times 10 to the 23rd molecules CO2. I know it's a lot to write, squeeze it in. There really is no abbreviation for molecule, because you would write it as mole, and mole is a different thing. So, and you can't just do M, because that would be meter. All right. So do we have the unit that we're looking for? We've canceled our moles. We have molecules left. Is that what we were seeking? Yeah. So here, you got to be careful when you're doing your scientific notation on your calculator. We've learned this before. So we're going to type in 2.3, and then we're going to multiply by our Avogadro's number. Remember, 6.02, you have to do your scientific notation correctly. So second, and then this EE, and you're going to type 23, and you get an answer of 1.3, looks like 1.38 times 10 to the 24th, and the unit is molecules, CO2. Questions? So if you could do the conversions before, yay, you're good. If you couldn't, you may be struggling. Make sure you ask for some help. Remember, you have to use the right buttons on the calculator to get it to do the scientific notation. It may look like you're doing it right, but you know, you maybe didn't do it 100% correctly. So that's one conversion. Let me show you another one. You could be doing, how many grams, let's just do the same one, in 2.3 moles CO2. Okay? So we are now looking for grams instead of molecules. We're starting with the same number, 2.3 moles of CO2, and we're putting it over 1. Okay? If we go back, I know you guys are writing fast. This is why I don't do notes this way. If you go back to the original page and we're going from moles to grams, what number are we going to use? What value? This, or this? Molar mass. Right, we're going moles to grams. So we're going to use the molar mass. We have to do this process for our substance. So let's set it up and solve it. I'm going to solve it over here. So CO2. How many C's? 1. So C, there's 1 of them. How many O's? 2. Look up the masses. Carbon is, Carbon is 12. Oxygen is 16. Okay. Do the math. Add it together. This tells me 44 grams of CO2 equals 1 mole of CO2. That's my conversion factor. And that's what we're going to use in our fraction. Okay. What unit goes on the bottom of this fraction? The moles of CO2. So we have here in our calculation, we have 1 mole of CO2 and 44 grams CO2. Let's check our units to make sure we've canceled what we needed to. Do we have the unit that we were seeking? Yeah, we have grams, so we're just going to multiply. So 2.3 times 44 gives me 101.2 grams of CO2. So we have The 2.3 moles of CO2 yielded us 1.38 times 10 to the 24 molecules, but it weighs 101.2 grams. Okay? Let's do the last problem that it could be. So the last one would be how many liters in 2.3 moles of CO2. All right, starting with our 2.3 moles of CO2. Again, over 1. Bless you. And now we're going to use which conversion factor? Molar volume. So this 22.4 liters. Okay. What unit goes on the bottom? 1 mole of CO2. And then 22.4 liters of CO2 would go on the top. Let's check our units. Moles cancel. I have liters, which is what I needed to find. So I'm going to take 2.3 times 22.4, and I got 51.52 liters of CO2. All right, that's moles 3 different ways. You could go in the reverse. I could say how many moles is in 25 liters. You're just going to change your conversion order depending on what they give you. And I feel pretty confident that you guys can handle canceling your units in the right order.